Okay, so let's practice. We are doing an example, example number 1. We're on page 5. So this example is called Dr. Zeppo's class, and the JASP statistical software will be used to conduct a one-sample mean t-test using the Zeppo CSV file. This contains the test scores of 20 students in a fictitious Dr. Zeppo's psychology course. So let's pretend that Dr. Zeppo is having an argument with a fellow faculty member. The other faculty member adamantly believes that in the population of all students, the average score on the test is 70 points. But Dr. Zeppo, he disagrees and wants to conduct a t-test to try to disprove their colleague. So the t-test is going to use the following hypotheses. So the null hypothesis is that the mean or mu equals 70, and the alternative or H1 hypothesis is that the mean or mu does not equal 70. So let's move to page 6. So they're going to use the JASP statistical software to conduct the one sample mean t-test, and as we often do, they also are requesting a confidence interval to estimate the true population mean. And so let's go ahead and try to do this experiment and see if we can get the same results. So what we're going to do is we're going to go to the little hamburger up in the upper left corner, and we're going to go into our downloads, and we're going to open the Zeppo file. Okay. All right, so we have our file opened. Then we're going to go to the top of our screen, and we're going to select t-test, and we're going to do the one sample t-test. And we're going to open that up, okay? And it looks like that. And then we're going to move the, not the student ID, but we're going to move the variable of X, which is the test scores, over to the variables box. And then we're going to also go to the confidence intervals, and notice how we're doing a student t-test, which is correct. Our alternative hypothesis, the alternative hypothesis was that the mu1 does not equal 70, and our confidence interval is going to be estimated at 95% confidence. So let's see if our data matches. So let's look. We're on page 6 in our book. We see our one sample t-test and our t-score. Oops, we forgot one thing. So we have to go to our test value here, and we have to put 70 in there. Okay, so we put a 70 in there, and then we're looking at our output data. So we're looking here. Our t-score value is 1.080. That looks good. Our degrees of freedom is 19. Our population, our p-value is 0.293 right here. Looks good. The mean difference is 2.300. The lower confidence interval is reported at negative 2.156, and the upper bound of our 95% confidence interval is 6.756. And we can read the note here. Note that for the student t-test, the alternative hypothesis specifies that the mean is different. It does not equal 70, okay? So everything looks good there. We did a good job. So let's keep going. So what does this mean, right? All right. So again, the t-test statistic is 1.080 with 19 degrees of freedom and a p-value of 0.293. The confidence interval, if we put it in brackets, would be negative 2.156, comma, 6.756, close bracket. And note that is labeled, this is labeled 95% confidence interval for the mean difference. So this is not a confidence interval which would be estimating the mean. It is a confidence interval estimating the difference between the true population mean and the test value of 70. So with some algebra, we can shift this confidence interval 70 points to the right so that it is estimating the population mean instead of the difference. So then we would do 70 plus the negative 2.156, comma, 70 plus 6.756, which will reduce the confidence interval. So in brackets, it would be 67.844, comma, 76.756, close bracket. Or if you'd like to avoid doing the math, you could change the test value to 0. And just remember that you'll need to change it back to the correct test value before you actually would copy down your test statistic and p-value. So let me show you this. So again, if we adjusted that and made it 0 for our test value, then it would get exactly what we did by adding 70 to these values, and we get the confidence interval 67.84, comma, 76.76. And then that changes our t value and our p value, so we have to go back and change this to 70. Because our t value is 1.080, the p value is 0.293 for this hypothesis, okay, of the null and the alternative. All right, so because the p-value for this test is 0.293, that is larger than the standard 0.05 alpha level, so we're gonna fail to reject the null hypothesis. There is not sufficient evidence here in our software to state that the population mean is different from 70 points. So these results are not statistically significant, and therefore, unfortunately, Dr. Zeppo, he cannot conclude, right? There is not sufficient evidence for Dr. Zeppo to conclude that his colleague was incorrect, okay? So how do we write this in APA format? So we could say, with a sample mean of 72.3 points, okay, standard deviation, and how do we get that? So we go here, descriptives. Okay. So we would say with a sample mean of 72.3, okay, right here, standard deviation of 9.5, there is not sufficient evidence to conclude that the population mean is different from, and then we go back and we add our one sample t-test. Okay. And we do 70 here. And we do our confidence interval here. So again, we're using the descriptive, which we can also just check here. And so again, with a sample mean of this 72.3 points, standard deviation 9.5, there is not sufficient evidence, because of our p-value here, not sufficient evidence to conclude that the population mean is different from 70 points. Okay, we have our 70 here. And then we write t in parenthesis 19, right? That's our degrees of freedom, equals 1.08, comma, p 0.293, 95% confidence interval, and then we can go back here and put a 0 and report the upper bound of the confidence interval, open bracket 67.8, comma 76.8, close bracket. Okay. So then again, the 19 in our degrees of freedom, right, that is in the parenthesis, that is the value of n minus 1. That's how we get that calculation. So n equals 20. So 20 minus 1 gives us 19 degrees of freedom. So yes, the 19 in the parenthesis is the degrees of freedom. And degrees of freedom are typically presented again in parenthesis following the abbreviation for our t-test. So t, comma, t parenthesis 19. And that checked out. Let's do one more example. The next one that we're going to do is, so we're going to close out of this, don't save, and we're going to go and we're going to get this file. So we're going to open up Parenthood. We're going to hit download. Okay, and then we're going to open up our file. And we're going to maximize this. We're going to go to the little hamburger. We're going to open up computer downloads. And we're going to open up this file here. There we go. That's the first step. So this is our second example for example number 2, bottom of page 6. We're looking at Danny's sleep. So for this example, we're going to use the Parenthood CSV file, and we're going to look specifically at Danny's sleep variable, which is the measure of how much sleep Danny had the night before that their grumpiness was measured. So let's say that we want to know if there is evidence that on average, Danny gets less than the recommended 8 hours of sleep per night. Okay. Let's move to page 7. So we are comparing the means of one group to a given hypothesized population parameter. So we will be using a one sample t-test, okay? We want to know if the population mean is less than 8. So this will be the left-tailed t-test. And we're going to write that our t-test is going to use these hypotheses. So the null hypothesis, or H0, is that our mean, or mu, would be greater than or equal to 8 hours. And then the H1, or the alternative hypothesis, would be that our mu is actually less than 8 hours, so less than 8. So when we conduct our one sample mean t-test, because we're just looking at that one variable, we again will go into our software here, and then we're going to, we opened up our file, and then we will go to t-test, do the one sample t-test, okay? We will move Danny's sleep over to the variables box, and because our value that we're interested is 8 hours, we're going to go to the test value, and we're going to put 8 here. And then we're going to add our 95% confidence interval. All right, so let's compare. We're looking at page 7, and we're going to make sure we set everything up properly. So yes, we moved our variable. We have a student t-test, which is what we want, not a z-test or the Wilcoxon signed rank test. We updated our test value because that is what we wrote in our hypothesis test. And we added our confidence interval. And if we want, we can also add descriptives, just for fun. So we know that we had n equals 100 values, and the degree of freedom is 100 minus 1, or 99. All right, so that looks good. And the only other thing we have to change is our test value is actually not the regular equals or not equals, it's the less than. We want to know if our variable is actually getting less than the recommended 8 hours of sleep. So let's take a look. So again, we did a one sample t-test. Our t-value came out as negative 10.19. Degrees of freedom is 99. It is significant. Our p-value is less than 0.001. Mean difference is reported as negative 1.035. The lower bound is negative infinity. The upper bound is negative 0.866. Our mean is, let's see, 6.97. Standard deviation 1.02. And there we go. So everything matched up. We did our output properly. So as we can see, this test has a t-test statistic of negative 10.186 with 99 degrees of freedom. P-value is less than 0.001. Confidence interval for the mean difference. Again, our example was that the difference between the mean and 8 is what we wanted to calculate. And we have our confidence interval of negative infinity, comma, negative 0.866. All right. So because our hypothesis test was a right-sided test, our software constructed a right-tailed confidence interval. A right-tailed confidence interval provides an upper bound for a parameter, which indicates the maximum value that it is expected to reach with a certain level of confidence. So if we converted this to a 95% confidence interval for the mean by adding an 8 to each side, then we could say that we'd have a right-tailed 95% confidence interval for the mean of negative infinity, comma, 7.134. So then to interpret this, we could say that we are 95% confident that the population mean is 7.134 hours or less. So here's another example of how we could summarize this data. So with a sample mean of 6.97 hours, again, we get that from our descriptives box. Standard deviation equals 1.02. There is evidence that the population mean is less than 8 hours. T parenthesis 99 equals negative 10.19. That's our T value, comma, P less than 0.001, comma, 95% CI equals negative infinity, comma, 7.13. So hold on here. I'm going to double check this. And there it is. So if we took out the 8 and put in a 0, then we get the negative infinity, comma, 7.13. Okay. But then we have to make sure that we change it back, otherwise our t-score is wrong. Okay. All right, that was a good example. So we're going to pause here.